Okay, ladies and gentlemen, we're looking at section 4.1 and 4.2. This section deals with what are called systems of linear equations. Now, by definition, a linear system, is basically nothing more than two equations of lines. So you remember your y equals mx plus b? If I have two of those and I'm looking at them at the same time, that's called a linear system. A solution of a linear system is an ordered pair that makes them both work. Now, what that really means in English, if I want you to solve a linear system, I want you to find out where the two lines cross. So, here's the first question on this for these three graphs below. How many solutions does each system possess? This is called a linear system because you see two lines. How many times do the two lines cross? Once. Therefore, there's one solution. This linear system, how many times do the two lines cross? Never. So there are 0 solutions. Now, even though you can't see it here, when I was in class, I was able to move this around for my students on the smartboard. There's actually one line under the line that you see. So there are two lines here. They're just on top of each other. Well, if two lines touch all the time, there are infinitely many solutions, correct? Every point on the line would be in common. So infinite number of solutions. Part 2. Is the system consistent or inconsistent? Consistent means there's at least one place they touch. At least one. Well, obviously this first drawing is consistent because there's one. This drawing would be inconsistent since they never touch. And this drawing would be consistent because there's at least one place they touch. In fact, there's infinitely many. Last question. Are the equations independent or dependent? Best way for me to explain that to you. The last system is called dependent. A dependent system means the lines are way too dependent on each other. They're always together. Okay, it's like codependency in a human relationship. If you're with somebody too much all the time, it's not good. Well, this, when one line's on top of another, that is referred to as a dependent linear system. Where the two lines are parallel, that is very independent. I mean, my goodness, those two lines don't ever see each other, correct? Independent. And this first place here where you see the cross or the X, that's also called an independent system because they only meet one time. So a dependent system is basically where they meet way too much, and independent means they either never meet or they just meet once. Okay. If I give you the linear system negative 6x plus 7y equals 29, and I give you the linear system 3x plus y equals 6, or the linear equation 3x plus y equals 16, and I want to know if the ordered pair 5, 1 is a solution of the system, I check it by plugging in. And the only way this ordered pair can be a solution of the system is if it makes both equations true. It's just like an AND statement. So, let's check it in the first equation. We put a 5 in for x and a 1 in for y. So the first equation would become negative 6 times 5 plus 7 times 1 equals 29. And then we get negative 30 plus 7 equals 29. Nope, it isn't. That's absolutely wrong. So, is this ordered pair a solution of the entire system? No way. If it fails in the first equation, we don't even need to waste our time trying to get it to work in the second equation. No point. For an ordered pair to be a solution of a system, it has to make equation 1 true, and it has to make equation number 2 true. Suppose I gave you a picture of a linear system already drawn for you. Okay? Here's a picture, and I said, what is the solution of the system? What I'm asking you is, please, you've got to learn what this means. What is the solution of the system means in English? Where do the lines touch? Now I realize this is a pretty small graph, and on your test it will certainly be larger, but I have the cursor right now on the point of intersection. When you read up, you can see x is 2, and when you read to the y-axis, you can see y is negative 2. So the solution of the system would be the ordered pair 2, negative 2. That is the place where the lines touch. So if somebody already gives you a graph, you're in really good shape. Okay? Now the next one, we're going to actually do the graphing on our own, and I'm going to pick this up in the next video.